Right now, as you watch this video, you are hurtling through an incomprehensible void at over 600 kilometers per second. You're standing on a rock that's spinning through absolute nothingness. And here's what will shatter everything you think you know about space. The universe isn't just empty. It's so catastrophically, mind-bendingly empty that if you could feel the true scale of this emptiness, your brain would refuse to process it. Let me give you a number that will haunt you. If you took all the matter in the observable universe, every planet, every star, every galaxy, every atom in your body, and spread it out evenly, you would have 1 hydrogen atom per cubic meter. One single atom in a space the size of a washing machine. That's how empty the universe actually is. But here's where it gets truly disturbing. That emptiness? It's not passive. It's not just the absence of things. The void of space is an active, dynamic, quantum screening nightmare that's doing things we're only beginning to understand. And what we've discovered in just the last decade will make you question whether emptiness even exists at all. I'm going to take you on a 200-minute journey into this void. We're going to explore what astronomers call the coldest, darkest, most hostile environment in existence. We're going to meet the scientists who've dedicated their lives to understanding nothingness. And by the end, you're going to see the space between the stars very differently than you do right now. But before we dive into this abyss, do me a favor. If you're ready to have your mind completely rewired about the nature of reality, smash that like button. Subscribe and hit the notification bell, because this channel is dedicated to taking you to the edges of human knowledge. And drop a comment right now telling me where in the world you're watching from and what time it is. I want to know how many of us are contemplating the void together, scattered across this tiny rock in the cosmic ocean. Are you in Tokyo at midnight? New York at dawn? Mumbai in the afternoon? Let me know. Let's start with something that seems obvious. Look around you right now. Your room feels full, right? There's air, furniture, walls, your phone or computer. It feels solid, substantial, real. Now here's your first mind-blown moment. You're not looking at reality. You're looking at an elaborate illusion created by your senses. Even the solid matter around you is almost entirely empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be tiny specks orbiting at the outer walls. Everything in between? Absolutely nothing. The chair you're sitting on is 99.9999999% empty space. You are 99.99999999% empty space. You're essentially a ghost pretending to be solid. But the universe takes this to an entirely different level. In 1924, astronomer Edwin Hubble, yes, the guy they named the telescope after, made a discovery that broke astronomy. He proved that the fuzzy patches we saw in the night sky weren't clouds of gas in our galaxy. They were entire galaxies, millions of light years away. In one observation, Hubble expanded the known universe by a factor of hundreds of thousands. Think of it like this. Imagine you've lived your entire life in a house, believing that house was the entire world. Then one day, you open the front door and discover not just a neighborhood, not just a city, but billions of cities stretching to infinity in every direction. That's what Hubble did to human understanding. But here's what shook the scientific community even more. Between those galaxies was nothing. Vast, incomprehensible oceans of nothing. Let me make this concrete. The Andromeda Galaxy is our nearest major galactic neighbor. It's 2.5 million light years away. That means if you could travel at the speed of light, the fastest speed possible in the universe, it would take you 2.5 million years to get there. But here's the kicker. For most of that journey, you would pass through absolutely nothing. No stars, no planets, no dust, no atoms. Just void. The average distance between galaxies is about 10 million light years. To put that in perspective, if our galaxy were a dinner plate, the nearest similar plate would be about 20 feet away. But unlike dinner plates on a table, there's no table. There's no floor. There's no room. There's just ... nothing. In the 1930s, a brilliant and tragically overlooked astronomer named Fritz Zwicky was studying galaxy clusters and noticed something impossible. The galaxies were moving too fast. According to the visible matter, these galaxy clusters should have torn themselves apart billions of years ago. But they hadn't. Zwicky proposed something radical. There must be invisible matter we can't see, holding these clusters together through gravity. He called it dark matter. The scientific community largely ignored him for decades. They thought he was wrong, eccentric, too far ahead of his thinking. Turns out, Zwicky was right. Today we know that 85% of all matter in the universe is this invisible dark matter. We can't see it. We can't touch it. We can only detect it by how it bends space and affects the motion of visible matter. In other words, most of the matter in the universe is hiding in the emptiness. But wait, because it gets more unsettling. Here's a question that seems simple, but will lead us down a rabbit hole. How cold is empty space? You might think, well, it's really cold, right? And you'd be both right and completely wrong in ways that will make your head spin. The temperature of the cosmic void is 2.7 Kelvin. That's negative 270.45 degrees Celsius, or negative 454.81 degrees Fahrenheit. It's almost as cold as physically possible to get. Absolute zero, the point where atoms stop moving, is 0 Kelvin. We're only 2.7 degrees away from that. But here's what will blow your mind. That 2.7 Kelvin isn't the temperature of nothing. It's the temperature of something. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were trying to eliminate background noise from their radio antenna in New Jersey. They kept detecting a persistent hiss, a microwave signal coming from everywhere in the sky all the time. They thought it was bird droppings on the antenna. They literally cleaned bird poop off their equipment, thinking that would solve the problem. It didn't. What they had discovered completely by accident while cleaning up bird poop was the echo of the Big Bang itself. This 2.7 Kelvin temperature is the cooled down afterglow of the moment the universe exploded into existence 13.8 billion years ago. That faint microwave radiation is everywhere, filling all of space, a cosmic background hum that proves the universe had a beginning. Think of it like this. Imagine setting off a massive firecracker in a closed room. The initial explosion is bright and hot, but even hours later, you could still measure the residual heat in the air. The cosmic microwave background is that residual heat, except the room is the entire universe, and the hours is 13.8 billion years. Penzias and Wilson won the Nobel Prize for their accidental discovery. But here's the truly wild part. This discovery meant that empty space isn't empty. It's filled with ancient light, stretched out and cooled down by the expansion of the universe itself. But the temperature story gets even stranger when we zoom in. In 1995, physicists Eric Cornell and Carl Wieman achieved something that seemed impossible. They cooled a gas of rubidium atoms to 170 billionths of a degree above absolute zero, far colder than the emptiest parts of space. At that temperature, atoms stop behaving like individual particles and merge into a single quantum entity called a Bose-Einstein condensate. At these extreme temperatures, matter does things that shouldn't be possible. Liquids flow upward, defying gravity. Light stops moving. Atoms exist in multiple places simultaneously. The normal rules of physics break down. Here's why this matters for understanding cosmic emptiness. It revealed that temperature isn't about hot or cold. It's about motion. Temperature is the average kinetic energy of particles. The colder something gets, the slower its particles move. At absolute zero, particles would stop moving entirely. But here's the quantum twist that will haunt you. Even at absolute zero, particles never actually stop moving. There's something called Zero-point energy, a fundamental quantum jitter that exists even in the coldest, emptiest possible space. Even nothing has energy. The universe is filled with this quantum foam, this seething background of virtual particles popping in and out of existence. Empty space at the quantum level looks like a roiling ocean of creation and annihilation happening trillions of times per second in every cubic centimeter. So when we say space is cold and empty, we're not describing reality. We're describing the limitations of our senses and our everyday experience. The void is neither truly cold nor truly empty. It's something far stranger. Now let's zoom out and look at how this emptiness is structured. Because here's what will absolutely wreck your sense of scale. The emptiness isn't random. It has architecture. It has structure. And that structure reveals something profound about the nature of the universe itself. In the 1980s, astronomers started mapping the three-dimensional positions of galaxies. They expected to find galaxies scattered randomly throughout space, like salt sprinkled on a table. What they found instead was so shocking that some scientists initially refused to believe the data. Galaxies aren't randomly distributed. They form vast sheets and filaments surrounding enormous voids. The structure of the universe looks like soap bubbles, thin walls of galaxies surrounding vast empty spheres. These voids are the largest structures in the universe, some spanning 500 million light-years across. Let me give you a sense of scale that will break your brain. Our entire local group of galaxies, including the Milky Way, Andromeda, and about 80 smaller galaxies, would fit comfortably inside one of these voids with room to spare. Imagine an empty sphere so large that you could fit 100,000 Milky Way galaxies inside it, and there would still be vast stretches of nothing between them. The Boat's void, discovered in 1981, contains only 60 galaxies in a region where we would expect to find 2,000. It's a sphere of near-nothingness, 330 million light-years across. If the Milky Way were in the center of the Boat's void, we wouldn't have known other galaxies existed until the 1960s. Our entire view of the cosmos would have been fundamentally different. Think of it like this. Imagine you're a fish in a massive ocean, but instead of water everywhere, you live in a thin film of water coating the inside of a bubble. Outside your bubble film is more emptiness, and beyond that, more bubble films with other fish. That's the structure of our universe islands of matter in an ocean of void. But here's where it gets cosmically weird. This structure wasn't random. It was determined in the first fraction of a second after the Big Bang. Physicist Alan Guth proposed in 1981 that the universe underwent a period of inflation, an exponential expansion that happened faster than the speed of light in the first 10 to 32 seconds of existence. That's 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 fluctuations were stretched from subatomic scales to cosmic scales. Those tiny quantum ripples became the seeds of galaxies, the patterns of slightly more dense and slightly less dense regions determined where matter would eventually clump together to form galaxies and where it would remain empty. The voids we see today are the descendants of quantum probability waves from the first instant of creation. Let that sink in. The emptiness around us, the voids spanning hundreds of millions of light years, were determined by quantum uncertainty in the first trillionth of a trillionth of a trillionth of a second after the Big Bang. The architecture of nothingness was built before the universe was even a second old. But there's an even more unsettling discovery about these voids. Recent observations show that the voids are growing. As the universe expands, the empty regions are getting emptier. Galaxies are being stretched apart. In the distant future, if the expansion continues accelerating, galaxies outside our local cluster will recede beyond the cosmic horizon. They will be moving away from us faster than light can travel. Their light will never reach us. From the perspective of distant civilizations, it will be as if we never existed. Eventually, in trillions of years, an intelligent being in a galaxy like ours would look up at the night sky and see only their own galaxy. The rest of the universe would have receded beyond visibility. They would think they lived in a small universe consisting of one galaxy surrounded by infinite emptiness. They would be wrong, but they would have no way to know it. We are living in a privileged moment in cosmic history where we can still see the larger structure. We can still observe the distant galaxies. We can still measure the ancient light from the Big Bang. Future civilizations won't have that luxury. Let's talk about something that seems obvious, but reveals a deep truth about the void. Space is silent. There's a famous tagline from the movie Alien. In space, no one can hear you scream. This isn't just a horror movie gimmick, it's physics. And the reason why will take us into some of the most profound discoveries about the nature of emptiness. Sound is a pressure wave traveling through a medium. When you speak, your vocal cords vibrate, pushing air molecules. Those molecules bump into neighboring molecules, creating a wave of compression that travels to someone's ear, where it vibrates their eardrum. No medium means no sound. In the vacuum of space, there's no air, no molecules to bump into each other. If you were floating in the void and a massive explosion happened next to you, a supernova detonating with the energy of 1 billion nuclear bombs, you would hear absolutely nothing. You'd see it. You'd feel the radiation. But you'd hear silence. But here's what's fascinating. The universe isn't completely silent. In 2003, NASA scientists analyzing data from the Chandra X-ray Observatory discovered something remarkable. There's a sound wave propagating through the hot gas in the Perseus galaxy cluster. This wave has been ringing for 2.5 billion years, creating ripples in the thin, hot plasma that fills the space between galaxies. The pitch of this sound is B-flat, but 57 octaves below middle C. That's 1,000,000 billion times deeper than anything the human ear can detect. If you could hear it, it would be the lowest note in the universe. Think of it like this. Imagine dropping a stone in a pond, but the pond is 250 million light years across, and the ripple has been spreading for billions of years. That's the scale of sound in space. But there's an even stranger way the universe sounds. In 2015, scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time. These are ripples in space-time itself, created when massive objects like black holes collide. When converted to sound waves, these gravitational waves make a distinctive chirp as the black holes spiral together and merge. This was one of the most important discoveries in physics in the last century. Einstein predicted gravitational waves existed in 1916, but thought they'd be too weak to ever detect. It took 100 years and some of the most sensitive instruments ever built to prove him right. The LIGO detectors can measure changes in distance smaller than 1/10,000th the diameter of a proton. To put that in perspective, if the distance from Earth to the nearest star were shrunk to the thickness of a human hair, LIGO could detect a change smaller than an atom. What does this have to do with emptiness? Everything. Gravitational waves are distortions in the fabric of space itself. When they pass through you, which is happening right now from distant cosmic events, you are being stretched and compressed. The space between your atoms is expanding and contracting. The emptiness inside you is rippling with the echoes of colliding black holes billions of light years away. You are not separate from the cosmic void. You are a temporary pattern in it, being constantly reshaped by waves in spacetime traveling across the universe. But here's the truly mind-bending part. If you could listen to the universe at all scales, you'd hear a symphony. the low rumble of galaxy cluster sound waves, the chirps of merging black holes, the hiss of the cosmic microwave background, the quantum foam bubbling at the smallest scales. Silence doesn't exist. Even the emptiest parts of space are humming with energy, vibrating with waves, singing songs that have been echoing for billions of years. The void is not dead. It's alive with information, with energy, with structure we're only beginning to understand. And speaking of things we're only beginning to understand, what I'm about to tell you next will fundamentally challenge your understanding of what empty means. Because scientists have discovered that the vacuum of space isn't just filled with quantum fluctuations and ancient light. It's filled with something that makes up 68% of everything that exists. And we have absolutely no idea what it is. Before we dive into that mystery, if you're still with me, drop a comment telling me which concept so far has blown your mind the most. Is it the quantum foam? The cosmic sound waves? The structure of voids? I read every comment, and your engagement helps more people discover these mind-bending ideas. In 1998, two teams of astronomers studying distant supernova made a discovery so shocking that it won them the Nobel Prize and shattered our understanding of the universe. They were trying to measure how much the expansion of the universe was slowing down, assuming that gravity from all the matter in the cosmos would be gradually pulling everything back together. Instead, they found the opposite. The expansion of the universe isn't slowing down. It's speeding up, accelerating. Every moment, the universe is expanding faster than the moment before. This made no sense. It violated everything we knew about gravity, about matter, about physics itself. It was like throwing a ball in the air and watching it accelerate upward instead of falling back down. The only explanation, something in the vacuum of space is pushing outward, counteracting gravity. The scientists called it dark energy, though that's really just a placeholder name that means we have no idea what this is. Here's what will break your mind. Dark energy makes up about 68% of all the energy in the universe. Dark matter, that invisible stuff we mentioned earlier, makes up another 27%. The normal matter that makes up everything we can see, every star, planet, galaxy, every atom in your body, is only 5% of what exists. We are the minority constituent of reality. We are the cosmic afterthought. And 68% of everything is this mysterious force emerging from empty space itself. Let me put this in perspective with an analogy. Imagine you spent your entire life studying water, its properties, how it flows, how it freezes. You understand water completely. Then one day, someone tells you that water is only 5% of the ocean. The other 95%? Something invisible that you can't detect directly, can't touch, can't taste, but that completely determines how the ocean behaves. That's where we are with the universe. We've studied the 5% of normal matter for centuries and built sophisticated theories about it. But the other 95%? It's a complete mystery. Here's what we know about dark energy. It's uniform throughout space. It doesn't clump together like matter. Its density stays constant even as space expands, and it creates a kind of negative pressure that pushes space apart. In 1916, Einstein introduced something called the cosmological constant into his equations, a term representing the energy of empty space. He later called it his biggest blunder because he thought it was unnecessary. Turns out, it might be his greatest insight. The cosmological constant might be dark energy. But here's the problem that keeps cosmologists awake at night. When quantum physicists calculate how much energy the vacuum of space should have based on quantum field theory, they get an answer that's 10,120 times larger than what we observe. That's a 1 followed by 120 zeros. It's not just wrong, it's the worst prediction in the history of science. Think about how wrong that is. If your GPS was off by that factor, it would place you in a different galaxy. If your cooking recipe was off by that factor, you'd be adding quadrillions of tons of salt to your soup. We have two incredibly successful theories, general relativity and quantum mechanics, that both predict the energy of empty space should exist. But when we try to calculate it, we get nonsense. This is called the cosmological constant problem, and it's one of the biggest unsolved mysteries in physics. Some scientists think dark energy might be changing over time. Others think it might be evidence of extra dimensions beyond the three of space and one of time that we experience. Still others think it means we need to completely rewrite our theories of gravity and space. What we do know is this: the emptiness between galaxies is not passive. It's not neutral. It's actively pushing the universe apart, determining the ultimate fate of everything that exists. Now let's talk about something that connects all this cosmic emptiness to you personally. The void is hostile to life in ways that are almost creative in their cruelty. Imagine for a moment that you were suddenly transported into the void between galaxies. What would happen? First, you'd suffocate. Obviously, you need oxygen, and there's none in space. But you'd have about 15 seconds of useful consciousness before you passed out. Here's what would happen in those 15 seconds. The air in your lungs would expand as the pressure dropped to near zero. If you held your breath, your lungs would rupture. Your blood wouldn't boil. That's a myth from movies. But the water in your tissues would vaporize, causing your body to swell to about twice its normal size. The moisture on your tongue, your eyes, your nose would evaporate instantly in the vacuum. You'd feel a strange fizzing sensation as dissolved gases in your bodily fluids formed bubbles like a can of soda being opened. After about 10 seconds, the lack of oxygen would cause your vision to tunnel and darken. You'd lose consciousness around 15 seconds. Within 90 seconds, you'd be dead. But here's what's fascinating. Those aren't the worst things the void would do to you. The real danger in space is radiation. Without Earth's atmosphere and magnetic field protecting you, you're exposed to cosmic rays' high-energy particles accelerated by supernovae, black holes, and other violent cosmic events. These particles are moving at near the speed of light with enough energy to pass straight through your body, tearing through DNA and shredding cells. In deep space, far from any star, the radiation exposure is actually lower than near a star. But it's still enough to give you a lethal dose within days or weeks. The Apollo astronauts reported seeing flashes of light, even with their eyes closed, cosmic rays passing through their eyeballs, triggering the retinas. Think of it like this: space is like an ocean filled with invisible bullets flying in every direction. Most of them pass through you harmlessly, but enough of them hit to cause catastrophic damage. Then there's the cold. We talked about space being 2.7 Kelvin, but here's the thing: you wouldn't freeze instantly. That's another movie myth. In the vacuum of space, there's no air to conduct heat away from your body. You'd lose heat only through radiation, which is a relatively slow process. You'd actually overheat before you froze. Your body generates heat through metabolism, and with no way to cool down through sweating or breathing, your internal temperature would start rising. Of course, you'd be dead from asphyxiation long before you had to worry about either freezing or overheating. But let's say you had a perfect spacesuit protecting you from all of these immediate dangers. Could you survive in the void? Astronauts on the International Space Station do, right? Well, not exactly. The ISS orbits within Earth's magnetosphere, the protective bubble of magnetic field that shields us from cosmic radiation. Astronauts are still experiencing more radiation than on Earth, which is why their exposure time is limited. Beyond Earth's magnetosphere, out in the true void, the radiation environment is far more severe. For a mission to Mars, astronauts would be exposed to about 300 millisieverts of radiation during a round trip. That's equivalent to about 150 chest X-rays. It would increase the lifetime cancer risk by about 5%. But here's the truly sobering thought. Mars is right next door in cosmic terms. Going anywhere beyond our solar system would require journeys lasting years or decades, even at the highest speeds our current technology can achieve. The nearest star, Proxima Centauri, is 4.24 light-years away. With our fastest spacecraft, it would take about 80,000 years to get there. That's not a typo. 80,000 years. Modern humans have only existed for about 300,000 years. Civilization has only existed for about 10,000 years. The void between stars is so vast that it might as well be infinite for any civilization limited to sublight travel. The emptiness is a prison, isolating every star system from every other. Unless we find a way to travel faster than light, which according to Einstein is impossible, or unless we can extend human lifespans dramatically, or unless we can put people in suspended animation, the void between stars might be permanently beyond our reach. Some scientists think this might be the answer to the Fermi paradox, the question of why we haven't seen evidence of alien civilizations despite the vast number of potentially habitable planets. Maybe intelligence emerges frequently in the universe, but the voids between stars are too hostile, too vast to cross. Every civilization remains trapped in its own star system, separated by unbridgeable gulfs of emptiness. Let's talk about something that sounds like a joke, but leads to profound insights. How fast does darkness travel? Your first reaction might be, darkness doesn't travel. It's just the absence of light. But think deeper. When you turn off a light, darkness doesn't suddenly appear everywhere at once. It spreads at a specific speed. That speed is the speed of light. When you flip a light switch, the light bulb stops emitting photons. But the photons already emitted continue traveling away at light speed. A darkness expands behind them like a shadow growing across the cosmos, moving at exactly 299,792,458 meters per second. This seems like wordplay, but it reveals something profound about the void. Information can only travel at finite speeds, and that limitation shapes the structure of what we can know about the universe. In 1905, Einstein published his theory of special relativity, which proved that nothing can travel faster than light. This isn't a technological limitation. It's a fundamental feature of space-time itself. Light speed isn't really about light. It's about causality, about the maximum speed at which cause can affect effect. Here's why this matters for understanding cosmic emptiness. It means the universe has an edge. Not an edge in space, but an edge in time. The universe is 13.8 billion years old. Light travels at a finite speed. Therefore, we can only see objects whose light has had time to reach us since the Big Bang. Beyond that distance, about 46.5 billion light years away, is the edge of the observable universe. Wait, you might be thinking, if the universe is 13.8 billion years old, shouldn't we only see 13.8 billion light years? Great question. The answer reveals something mind-bending about the expansion of space. While light was traveling toward us from distant galaxies, space itself was expanding, stretching the distance. It's like running on a treadmill that's accelerating. You're moving forward, but the ground is stretching behind you faster than you're running. Because of this expansion, the edge of the observable universe is actually 46.5 billion light years away in all directions, making the observable universe about 93 billion light years across. But here's what will break your brain. Beyond that edge, the universe continues. There are galaxies, stars, potentially civilizations, whose light will never reach us. Not because they're too dim or too far, but because the space between us and them is expanding faster than light can cross it. Think of it like this. Imagine you're on one end of an infinitely long rubber band, and someone else is on the other end. You start walking toward each other, but the rubber band is being stretched faster than either of you can walk. You'll walk forever and never meet. You're both moving, but the space between you is growing faster than you can close it. That's what's happening in the universe. There are galaxies we can see now that we will never be able to reach, even if we could travel at the speed of light, because the space between us is expanding too fast. This creates something called the cosmic event horizon, a bubble around us beyond which we can have no causal contact. Events beyond that horizon might as well not exist as far as physics is concerned. They can never affect us. We can never affect them. In 2011, Nobel laureate Frank Wilczek calculated that due to the accelerating expansion of the universe, eventually the cosmic event horizon will shrink. Galaxies that we can see today will disappear beyond it. One by one, the lights will go out. In about 100 billion years, if the acceleration continues, only the galaxies in our local cluster gravitationally bound to us will remain visible. Everything else will have receded beyond the cosmic horizon. Future astronomers in those distant times will look up at a night sky with only their local cluster visible. They will see no cosmic microwave background, no distant galaxies, no evidence of the Big Bang. They will think they live in a small, static universe surrounded by infinite emptiness. They will be wrong, but they will have no way to discover the truth. The expansion of the void will erase the evidence of the universe's history. We are living in a unique epoch late enough after the Big Bang to have complex structures like galaxies and stars and life, but early enough that we can still see the full history of the cosmos. Here's a question that will flip your understanding. What if the emptiness isn't the enemy of life, but its prerequisite? Think about where the atoms in your body came from. The hydrogen was forged in the Big Bang, but the carbon, nitrogen, oxygen, the elements that make up your body, were created inside dying stars. Every atom heavier than helium in your body was forged in the nuclear furnace of a massive star. When that star exhausted its fuel, it collapsed and exploded in a supernova, scattering those atoms into space. Those atoms drifted through the cosmic void for millions of billions of years until gravity pulled them together into a new cloud of gas and dust, which collapsed into our solar system, which formed Earth, which gave rise to life, which eventually became you. You are made of stardust, as Carl Sagan famously said. But here's what's less famous. You are also made of the void. The journey those atoms took from the heart of a dying star to your body required the emptiness of space. In a densely packed universe where matter filled all available space, those atoms would have been trapped. They couldn't have traveled. They couldn't have mixed with other atoms from other stars. The diversity of elements necessary for complex chemistry, for life, requires the void as a medium of exchange. Think of it like this. A library isn't just books. It's also the empty spaces between the books that allow you to remove one book and put another in its place. The organization, the function, the purpose of a library requires emptiness as much as it requires books. The void is the cosmic library shelf. It's the space that allows matter to organize itself into complex, interesting structures. But there's an even deeper way the void creates life. In 1961, physicist Frank Drake formulated an equation to estimate the number of communicating civilizations in our galaxy. The Drake equation multiplies together factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and so on. When you plug in reasonable numbers, you get a result suggesting there should be many thousands or even millions of technological civilizations in our galaxy alone. Yet we see no evidence of them. This is the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked, "Where is everybody?" One possible answer: the void protects us. If star systems were packed closely together, an expanding civilization could colonize neighboring systems easily. An aggressive expansionist species could spread across the galaxy in just a few million years and eye blink in cosmic time. But star systems aren't packed together. They're separated by light years of void. This isolation might act as a firebreak, preventing any single civilization from dominating the galaxy. It might give each species time to mature, to develop wisdom, before encountering others. The emptiness might be a protective moat around every inhabited world, allowing life to develop independently without being overrun by older, more technologically advanced species. In 2015, astronomers discovered that the Milky Way sits in a vast underdense region called the KBC void. We're in one of the emptier parts of the universe. This might not be coincidence. Less dense regions might be more favorable for life because they're subject to fewer disruptive events like nearby supernova or gamma-ray bursts. The void isn't just a passive backdrop. It's an active participant in the story of life, protecting us from cosmic catastrophes and providing the space for complexity to emerge. Now we need to zoom into the smallest scales imaginable, because what we discover there will completely obliterate your notion of what empty means. In 1948, Dutch physicist Hendrik Casimir predicted something that seemed impossible. He calculated that if you place two metal plates very close together in a perfect vacuum, they would be pushed together by ... nothing. Think about that. Two plates in a vacuum, the emptiest environment you can create, with no air, no particles, nothing between them. And yet they're pushed together by an invisible force. When this was finally measured in 1997, Casimir was proven right. This is called the Casimir effect, and it reveals something profound. The vacuum isn't empty. Even in the most perfect vacuum possible, space is teeming with virtual particles, pairs of particles and antiparticles that pop into existence and annihilate each other so quickly that they don't violate conservation of energy. Here's what's happening. Quantum mechanics tells us that energy and time are linked by Heisenberg's uncertainty principle. For extremely brief moments, you can borrow energy from the universe to create particle-antiparticle pairs, as long as you pay it back by having them annihilate before the universe notices. The time scale we're talking about is incomprehensibly small. A pair of particles might exist for y-21 seconds, a billionth of a trillionth of a second. But during that time, they're real. They have mass, charge, and momentum. They can interact with other particles. The vacuum is like a cosmic loan office, constantly lending and reclaiming energy, with transactions happening quadrillions of times per second in every cubic centimeter of space. The Casimir effect happens because the space between the plates is so small that only certain wavelengths of virtual particles can fit. Outside the plates, all wavelengths can exist. This creates a pressure difference, more virtual particles pushing from outside than inside, so the plates are pushed together. Think of it like this. Imagine you're in a room where invisible people are constantly appearing and disappearing, bumping into you from all sides. The bumps cancel out, so you don't feel anything. But now someone puts up walls very close to you. Fewer invisible people can fit between you and the walls, so you feel more bumps from the open side. The walls are pushed together. That's the vacuum. It's not emptiness, it's a seething foam of quantum activity. In 1974, Stephen Hawking discovered something even more bizarre. Black holes aren't completely black. They emit radiation because of this quantum foam at their event horizons. Virtual particle pairs appear at the edge of the black hole. Sometimes one particle falls in while the other escapes. From the outside, it looks like the black hole is emitting particles. This is called Hawking radiation, and it means black holes eventually evaporate. They lose mass over time as they radiate energy into the void. A black hole with the mass of our sun would take about 1,067 years to evaporate, far longer than the current age of the universe. But eventually, every black hole will dissolve into the vacuum, returning its energy to the quantum foam. Here's the truly mind-bending part. Hawking showed that this process destroys information. Everything that falls into a black hole, every particle, every pattern, every bit of information, is supposedly lost when the black hole evaporates. This violates quantum mechanics, which says information can never be truly destroyed. This is called the black hole information paradox. and it's been one of the biggest unsolved problems in physics for 50 years. Some of the smartest physicists alive have spent their careers trying to solve it. In 2004, Hawking himself conceded he was wrong, and that information must somehow be preserved, though exactly how remains a mystery. Leonard Susskind proposed that information is encoded in the Hawking radiation through quantum entanglement, a phenomenon Einstein called spooky action at a distance. When particles become entangled, measuring one instantly affects the other, no matter how far apart they are. If Susskind is right, then every particle of Hawking radiation escaping from a black hole is entangled with something inside it, preserving information in a quantum code written in the void. The vacuum isn't just teeming with virtual particles. It's a quantum information storage medium, potentially encoding everything that has ever fallen into every black hole in the universe. You think of emptiness as nothing, but at the quantum level, it's everything. It's a library containing the complete history of every particle that ever existed. It's a medium that connects every point in space to every other point through quantum entanglement. It's a phone of creation and destruction happening at scales so small and so fast that our senses can't detect it. The void isn't empty. It's the most densely information-packed thing in the universe. Let's shift gears and talk about something more human. What does contemplating the void do to our minds? Throughout history, humans have had complicated relationships with emptiness. Many of us fear it. The fear of empty space even has a name: kenophobia. It's related to agoraphobia, the fear of open spaces. At its root, it's a fear of being vulnerable, exposed, without protection. This fear probably has evolutionary origins. Our ancestors lived in a world where being exposed meant being vulnerable to predators. Open space meant danger. Emptiness meant no shelter, no resources, no safety. But here's what's fascinating. Contemplating cosmic emptiness can have the opposite effect. It can be profoundly therapeutic. There's a psychological phenomenon called the overview effect, first described by author Frank White in 1987. It refers to the cognitive shift that astronauts experience when they see Earth from space, a pale blue dot surrounded by infinite blackness. Astronauts consistently report that seeing Earth against the void fundamentally changes their perspective. Borders disappear. Political conflicts seem absurd. The fragility and unity of human civilization becomes viscerally obvious. The pettiness of daily concerns evaporates in the face of cosmic scale. Astronaut Edgar Mitchell, who walked on the moon during Apollo 14, described it as an explosion of awareness and a sense of universal connectedness. He said the experience was so profound that he spent the rest of his life studying consciousness and the nature of reality. Think of it like this. Imagine you've spent your entire life arguing with family members about who gets which room in your house. Then you're suddenly lifted up and shown that your house is a tiny speck on a vast planet, which is itself a tiny speck in a vast solar system, which is a tiny speck in a vast galaxy, which is a tiny speck in a vast universe. The argument doesn't just seem small, it seems absurd. This shift in perspective is called cosmic humility, and research suggests it has measurable psychological benefits. A 2018 study published in the Journal of Personality and Social Psychology found that experiences of awe, particularly from contemplating vast scales, increase social behavior, reduce feelings of entitlement, and promote generosity and cooperation. When you confront the void, you're forced to reckon with your insignificance. And paradoxically, this makes you more, not less, connected to humanity. But there's a darker side to contemplating emptiness. The philosopher Blaise Pascal wrote in 1670, "The eternal silence of these infinite spaces frightens me." He was describing what some call cosmic horror, the terror of confronting scales so vast and inhuman that they threaten to dissolve meaning itself. If the universe is so incomprehensibly large, if we're so cosmically insignificant, If everything we do will eventually be erased by entropy, then what's the point? This question has driven some people to nihilism, the belief that life has no inherent meaning. H.P. Lovecraft built his entire literary career on cosmic horror. His stories feature ancient beings so vast and alien that merely perceiving them drives humans insane. The void in Lovecraft's fiction isn't just empty. It's hostile to meaning, to sanity, to the human mind's ability to comprehend reality. But here's another way to think about it, proposed by existentialist philosophers like Albert Camus and Jean-Paul Sartre. The void doesn't erase meaning. It liberates us to create it. If the universe has no inherent purpose, then we're free to choose our own. If our lives are cosmically insignificant, then we're free to define significance on our own terms. The emptiness isn't a prison, it's a blank canvas. Camus wrote about Sisyphus, condemned by the gods to push a boulder up a hill for eternity, only to watch it roll back down. Most people see this as a symbol of meaninglessness. Camus saw it differently. The struggle itself toward the heights is enough to fill a man's heart. One must imagine Sisyphus happy. Think of it like this. If you're playing a video game and you discover that the game is finite, that it will end, does that make the game meaningless? Or does the temporary nature of the experience make it more precious? The void reminds us that everything is temporary. Stars will die. Galaxies will drift apart. Eventually, in 10,100 years or so, even black holes will evaporate, leaving only a thin soup of radiation expanding into infinite cold darkness. The heat death of the universe, maximum entropy, minimum complexity, the end of change itself. But that's trillions upon trillions of years in the future. Right now, in this incomprehensibly brief window of cosmic history, complexity exists. Consciousness exists. You exist. The void is the backdrop that makes this moment remarkable. Let's bring this down to a human scale and talk about a different kind of emptiness, the space between people. You're physically closer to other humans than ever before in history. Cities pack millions of people into small areas. The internet connects billions, and yet loneliness is epidemic. In 2018, the UK appointed a Minister for Loneliness to address what health officials called a public health crisis. How can we be surrounded by people and still feel isolated? Because physical proximity isn't the same as connection. You can be in a crowd and feel more alone than if you were in the wilderness. This psychological void between people mirrors the cosmic void in interesting ways. Just as cosmic voids are growing as the universe expands, the emotional distance between people seems to be growing despite technological connection. We have more ways to communicate than ever, but studies show that the quality of relationships, deep, meaningful connections, is declining. Think of it like this. Imagine the universe where galaxies are close together, constantly interacting and colliding. That universe would be chaotic but connected. Now imagine our universe, where galaxies are separated by vast voids, moving apart from each other. That's our social landscape islands of connection, separated by growing distances. But here's the fascinating part. Just as the cosmic void isn't truly empty, the space between people isn't truly empty either. There's a field of study called social physics that applies concepts from physics to human behavior. Researchers like Alex Pentland at MIT have discovered that human interactions follow patterns similar to particle interactions. Information flows between people like energy flows between particles. Social networks have structures similar to cosmic web structures, clusters connected by filaments with voids between them. When you feel lonely, you're not experiencing objective isolation. You're experiencing a subjective perception of emptiness. A feeling that the connections you have aren't sufficient. Someone living alone in a cabin might feel deeply connected to nature, to their thoughts, to their sense of purpose. Someone in a crowded city might feel desperately isolated. The void between people isn't measured in physical distance. It's measured in the quality of attention, understanding, and emotional resonance. Here's something that will blow your mind. You've never actually touched another person. At the atomic level, the electrons in your atoms repel the electrons in their atoms. When you think you're touching someone, you're actually feeling the electromagnetic force pushing back. There's always a tiny gap of void at the atomic scale between you and everything else. But that gap is where communication happens. Touch is actually the sensation of force fields interacting. Sound is vibrations traveling through the air. Vision is photons traveling through space. All communication requires emptiness to function. If atoms could actually touch, if electron clouds could overlap, matter would collapse. The void at the atomic level is what allows distinct objects to exist, to interact, to communicate. Similarly, psychological boundaries, the sense of being a separate self, might be necessary for genuine connection. You can't have a relationship without two distinct people. You can't have communication without space for the message to travel through. The loneliness you feel isn't evidence of cosmic isolation. It's evidence of your capacity for connection. You can only miss what you're capable of having. Throughout history, humans have tried to fill the void, both cosmic and personal, with meaning, stories, and purpose. Every religion, every philosophy, every artistic movement has been, in some sense, an attempt to answer the question, what do we do with the emptiness? Ancient religions filled the void with gods. The Greeks put deities in the stars. The Norse imagined cosmic trees connecting worlds. Hindu cosmology describes endless cycles of creation and destruction, with the void, called shunyata in Buddhism, being not empty but pregnant with potential. Medieval Christians saw the heavens as perfect, unchanging spheres with Earth at the center. The void beyond was where God resided. When Galileo's telescope, postmodernism responded by embracing the void. Philosophers like Jacques Derrida argued that meaning itself is void-like, always deferred, never fixed, constantly shifting. Artists like Mark Rothko painted vast fields of color, suggesting infinite depths. John Cage composed 433, a piece where musicians sit in silence for 4 minutes and 33 seconds, making the audience confront the sounds around them and the emptiness of expectation. But here's what's remarkable. Every attempt to fill the void has produced something beautiful. Religion gave us transcendent experiences and communities. Philosophy gave us frameworks for thinking about meaning. Science gave us understanding of the cosmos. Art gave us ways to express the inexpressible. The void isn't a problem to be solved. It's a creative constraint that generates innovation. Think of it like this. If a painter had an infinite canvas with infinite paint, they might never finish a painting. The limitations, the finite canvas, the finite palette force creativity. The void forces us to be creative about meaning, about purpose, about connection. In 2017, philosopher Philip Goff proposed a radical idea called cosmopsychism, the notion that consciousness might be a fundamental feature of the universe, like space and time. On this view, the void isn't dead or empty. It's the field of potential consciousness, and individual minds like yours are localized expressions of a universal awareness. This sounds mystical, but it's being taken seriously by some physicists and philosophers as a potential solution to the hard problem of consciousness, the question of how subjective experience arises from objective matter. Whether or not cosmopsychism is true, it represents a profound shift in how we think about emptiness. What if the void isn't the opposite of consciousness, but its prerequisite? What if awareness requires emptiness space for possibility, for change, for novelty? When you meditate, you don't add something to your mind. You create emptiness. You clear away the noise, the chatter, the constant stream of thoughts. And in that emptiness, clarity emerges, peace emerges, insight emerges. The void isn't the enemy of meaning. It's the space where meaning can emerge. Every sentence requires spaces between words. Every musical composition requires silence between notes. Every dance requires empty space for movement. Every relationship requires boundaries and personal space. Creation requires void. We've journeyed through cosmic voids, quantum foam, psychological emptiness, and philosophical meaning. But there's one final perspective shift that will tie everything together, a way of seeing the void that will change not just how you think about space, but how you think about yourself and your place in existence. Before we get there, I need you to do something. Look at the like button. Really look at it. If this video has expanded your mind, if it's given you a new way of seeing the emptiness around and within you, show it by hitting that button. And subscribe, because we're about to bring this all home in a way that will make you see your daily life differently. Here's the final mind-bending truth that connects everything we've discussed. You are not separate from the void. You are the void, temporarily organized into a pattern complex enough to observe itself. Let's break this down because it's the most important thing I'm going to tell you. We established earlier that you're 99.9999999% empty space at the atomic level. But it goes deeper than that. The atoms in your body are mostly void, but they're also temporary. Every atom in your body will eventually return to the cosmos. When you die, those atoms will disperse. Some might end up in plants, some in other animals, some in the ocean, some in the atmosphere. Over millions of years, they'll continue their journey through the cosmic void. But even while you're alive, you're constantly exchanging atoms with your environment. You breathe in oxygen atoms and breathe out carbon dioxide. You eat food and excrete waste. Every few years, most of the atoms in your body are replaced. The pattern that is you, your memories, personality, consciousness, isn't tied to specific atoms. It's a pattern of information, a process rather than a thing. You're like a wave in the ocean. The wave is real, but it's not made of special water molecules. It's a pattern moving through water, and the water molecules return to the ocean after the wave passes. Think of it like this. Imagine a whirlpool in a river. The whirlpool is real. You can point to it, measure it, throw a stick in, and watch it spiral. But the whirlpool isn't made of special water. Water flows through the whirlpool pattern continuously. The whirlpool is a self-sustaining pattern of organization in the flow. That's you. You're a self-sustaining pattern of organization in the flow of matter and energy through the universe. You're a whirlpool in the cosmic river. You're a temporary structure in the void. But here's what makes this profound rather than depressing. That pattern, the pattern that is you, has the ability to observe and understand the void it emerged from. The universe is 13.8 billion years old. For most of that time, it was just matter bouncing around according to physical laws. Then, at some point in the last few billion years, matter organized itself in such a way that it became conscious. Atoms arranged themselves into patterns that could observe, think, feel, and wonder about their own existence. You are the universe looking at itself. When you stare up at the stars, you're not separate from what you're observing. You're a part of the cosmos that has become aware of the whole. Cosmologist Carl Sagan said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." This isn't poetry. It's physics. It's literally true. Every atom heavier than hydrogen in your body was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, the carbon in your DNA, all of it was created in stellar furnaces and scattered through the void when those stars exploded. But it's even more profound than that. The very laws of physics that govern the cosmos are the same laws that govern your thoughts. When neurons fire in your brain, they're following the same electromagnetic principles that govern stars and galaxies. When you make a decision, you're demonstrating the same quantum uncertainty that governs particle interactions. You're not in the universe. You're not on Earth looking out at space. You are a localized manifestation of universal processes. The boundary between you and the void is arbitrary, conventional, useful for navigation, but ultimately illusory. Buddhist philosophers figured this out thousands of years ago with the concept of sunyata, emptiness, or voidness. They argued that the self has no inherent, independent existence. You exist only in relation to everything else. You're a node in an infinite web of causes and conditions, stretching back to the Big Bang and forward to the heat death of the universe. Modern physics has come to similar conclusions through completely different routes. Quantum entanglement shows that particles are fundamentally interconnected in ways that transcend space and time. The holographic principle suggests that all the information in a three-dimensional region of space might be encoded on its two-dimensional boundary, implying that what we think of as separate objects are really aspects of a unified whole. You are not a thing sitting in empty space. You are a process emerging from the relationships between things. You are the void, organized into a temporary pattern complex enough to ask, what is the void? So what do you do with this knowledge? How do you live, knowing you're a temporary pattern in an infinite void? Here's my answer. You live more fully, not less. Understanding the void doesn't diminish life. It amplifies it. When you grasp the incomprehensible improbability of your existence, when you understand the cosmic chain of events that had to happen for you to be here, when you realize that you're a way for the universe to experience itself, every moment becomes precious. You are 13.8 billion years of cosmic evolution, expressing itself as a conscious being for a brief flash of time. Every thought you have, every emotion you feel, every connection you make with another person is the universe doing something it can't do when it's scattered across the void as individual atoms. When you feel joy, that's the universe experiencing joy through you. When you create art, that's the universe creating art. When you love someone, that's the cosmos experiencing love. This isn't mysticism, it's perspective. You're not separate from the processes that created stars and galaxies. You're a continuation of those processes at a different scale. So here's how you live with the void. First, embrace impermanence. Everything is temporary. Your problems, your triumphs, your relationships, your life, your civilization, your species, your planet, your star. The voids between galaxies are growing. Eventually, everything will return to the cosmic void. This isn't depressing, it's liberating. If nothing lasts forever, then you're free to choose what matters to you now, without the burden of thinking it has to matter forever. Second, cultivate awe. Make time to contemplate scales larger than your daily concerns. Watch videos about space. Read about physics. Go somewhere with dark skies and look up at the stars. Let yourself feel small. That feeling of smallness isn't diminishment, it's connection. You're part of something vast and ancient and ongoing. Third, recognize your significance. Yes, you're cosmically small, but you're also incredibly rare. As far as we know, conscious beings like you are extraordinarily uncommon in the universe. Most of the cosmos is void, dead matter, radiation. You're one of the few parts that's aware, that thinks, that cares. That makes you cosmically important, not cosmically insignificant. Fourth, connect deeply. The voids between people, the loneliness, the isolation can be bridged, not by pretending they don't exist, but by acknowledging them and choosing to build connections anyway. Every deep relationship is an act of rebellion against entropy, against isolation, against the cold emptiness that dominates the cosmos. Fifth, create meaning. The universe doesn't hand you purpose. You have to create it. Choose what matters to you. Pursue it with intensity. Build, create, love, explore, question, wonder. Fill your personal void with whatever makes the brief spark of your consciousness burn brighter. Sixth, be kind. Everyone you meet is another temporary pattern in the void, just like you. They're facing the same cosmic absurdity, the same brief flash of consciousness in an ocean of emptiness. Whatever conflicts divide you are trivial compared to what unites you, the shared experience of being aware in a mostly unaware universe. The void teaches us that nothing is permanent, nothing is separate, nothing is guaranteed. And that's okay. Better than okay? It's beautiful. Think of it this way. You're at a party that's going to end. Everyone knows the party will end. Does that make the party meaningless? No. It makes it more precious. You dance while you can. You connect with people while they're here. You enjoy the music while it's playing. The universe is that party. You're here for an incomprehensibly brief moment in cosmic time. The void came before you and will be here after you. But right now, in this moment, you get to be part of the pattern, part of the cosmic dance. Don't waste it wishing you were more significant, or that things would last forever. Be significant now. Love deeply now. Create meaning now. Experience wonder now. We've traveled together through 180 minutes and billions of light years. We've explored the cold emptiness between galaxies, the quantum foam between atoms, and the psychological voids between people. We've met scientists who dedicated their lives to understanding nothingness and discovered that nothing isn't what we thought it was. Let me remind you of the key revelations from our journey. The universe is almost entirely empty space, 1 hydrogen atom per cubic meter if you spread all matter evenly. But that emptiness isn't passive or dead. It's filled with quantum fluctuations, dark energy, ancient light from the Big Bang, and the echoes of cosmic events billions of years old. The void has structured vast cosmic voids hundreds of millions of light years across, surrounded by filaments and sheets of galaxies. This structure was determined in the first instant after the Big Bang by quantum fluctuations smaller than an atom. Space is cold, but not silent. It rings with sound waves that have been propagating for billions of years. It vibrates with gravitational waves from colliding black holes. It hums with the quantum foam bubbling at the Planck scale. The void is hostile to life as we know it, but it's also necessary for life. Without the vast distances between stars protecting us, without the emptiness allowing atoms to travel from dying stars to new solar systems, without the cosmic voids allowing regions of lower density where life can develop relatively undisturbed, we wouldn't exist. Empty space isn't truly empty. It's filled with dark energy we don't understand, making up 68% of the universe. It's filled with virtual particles, constantly appearing and disappearing. It's filled with information encoded in quantum entanglement. The voids between galaxies are growing as the universe expands faster and faster. Eventually, distant galaxies will recede beyond the cosmic horizon, and future civilizations will live in a universe that appears small and static, unable to see the evidence we can still observe today. You are not separate from the void. You're a temporary pattern in it. Your atoms came from dying stars, scattered through cosmic emptiness, and assembled into the complex pattern that is your body and mind. When you observe the void, you are the void observing itself. And finally, the void doesn't erase meaning. It provides the space for meaning to emerge. The emptiness isn't the enemy of life. It's the canvas on which life paints itself. As we end this journey, I want you to do something. Tonight, or when you next have the chance, go outside and look up at the night sky. Each point of light you see is separated from you by incomprehensible voids. The light from those stars has traveled through billions of miles of nothingness to reach your eyes. You're seeing ancient light from stars that might not even exist anymore, traveling through space-time itself to create an image in your consciousness. And in that moment, you'll be what you've always been. A pattern of organization in the cosmic flow, a local decrease in entropy, a way for the universe to observe its own vastness. You'll be looking at the void, and the void will be looking back not as an enemy or an absence, but as the eternal context in which all existence occurs. The cold emptiness of the universe isn't something to fear. It's something to contemplate with wonder. It's the background that makes the foreground possible. It's the silence that makes music meaningful. It's the darkness that makes light visible. You are a brief candle flame in an infinite dark, and that's not tragic. It's magnificent. Thank you for taking this journey with me into the void. If this video changed how you see yourself in the cosmos, share it with someone who needs a perspective shift. Like and subscribe to join future explorations into the deepest questions of existence.